Welcome! Today we are looking at AC. Now, if you haven't seen automated or case guards videos on it, you should definitely start there, but essentially the efficiency and the output of the AC is heavily dependent on the connected pipe length. You can see this is outputting at 73 kelvins, but if I remove a pipe segment, this starts to climb. Now, if you are starting early game and just need some cold air to cool down your base, this setup is fine, it's easy to manage, but if you want a more complex system or closed loop system to avoid pushing toxins and stuff into your base, we need another solution. So we are going to eliminate the whole pipe length problem by just adding a volume pump to the input. Pretty much just like this. By adding a volume pump here on the input, the AC no longer gets to decide how much gas it pulls through. Rather, I decide how much gas the AC gets. So I can now manipulate the volume pump and thus the output on the AC. You can see it's outputting at 75 Kelvin right now, but I can turn my dial here and it should settle on 80 Kelvin in a few seconds. We have also completely eliminated the pipe length problem. I can now continue to add pipes here as much as I like, and the volume pump will rebalance out and try as good as it can to keep it at 80. This also works with all kinds of inputs and pressures. So the code that's controlling this volume pump is pretty much just a PID controller. I have one IC over here and you might recognize my PID controller code. I have already done a video on PID controller back in February, so you can go watch that. I'll not go very much into detail on how that works in this video. But essentially, we can now have a controllable AC and with a very variable input. So the next step is to make a closed loop system that doesn't take in or releases gases in any way. By adding another AC going the other way, we now have a closed loop. I have filled my red pipe here with CO2, which will be the hot side due to the color red, and then we have the blue side that will be our cold side. Now currently it's not very cold there and it's not a lot of gas in it. That's why the red AC isn't set up yet. It's still only the one PID controller running this one. But I wanted to show you a couple of things. First, you can see that the temperature here is dropping. Perhaps this is better. Pretty fast, but the temperature here is also rising pretty fast. If you want to use the heat here for anything, be my guest, but I'm going to just set up a radiator on this pipe just to exhaust that heat into the atmosphere. That will speed up the process a little bit, but the second thing I wanted to show you is if you want more capacity, you don't need to set up a completely a double system. We can just set up a new AC. Let's see. Atmospherics kit. Let's build one here. Oops, that's a filtration unit. Air conditioner. And we need some pipe. And a pump. and some cable. You see, we don't need to check the output on this AC because we already checked the output on that AC. So by just copying the setting from this volume pump to this one, we can presume this AC does the same, gives the same output. So let's quickly set this up. I've already coded this in, so just need to select a new volume pump and turn it on. We have now doubled the efficiency, but we don't need any extra code. We don't need the whole output thing on this one. We only need one input pump, and this doesn't cost a lot of power. Let's see, that's the wrong one. This pump uses 1.1 watts, so pretty cheap overall, and we could continue this as much as we want. If you're a little bit clever with your networks, you could do some clever batch writing, and yeah. So let's just wait until this pipe here gets more content, and I'll set up this AC. Okay, so the blue ACs have now been running for a while, and we have a little bit of pressure in the pipe here. And before we get this running, I want to quickly explain why we need this. We could just take this cold air and pump it straight into our atmosphere in the base or through a heat exchanger, but at some point this pipe is going to fill up and we have to deal with the pressure buildup. And we don't want to release that perfectly good air back into the atmosphere. It will probably just be above room temperature, and it's a lot more cost efficient to reuse it rather than just release it out. So that's why this AC is here, simply to recirculate the air back in to the system. So let's turn it on and see it running. Now you might think, doesn't it just go up to 200 degrees, while the temperature in the pipe here is almost 500? And that's correct, but it's actually not really important. And here comes the most surprising part. If you keep an eye on this temperature here, you can see that very fast it's going to drop below 80 Kelvin. But these blue ones are only releasing 80. So when this is dropping now to 79 in a second, you see why it doesn't really matter that this is only outputting at 200 degrees. And it's because the AC that's mainly cooling this blue pipe isn't actually the blue ACs. You can see how fast this is dropping, and these are still only releasing at 79, 80K. And this is dropping fast down to less than that. And that's because it's actually the red AC that's cooling this pipe the most. And we can see the same effect on the other side if I remove the radiators for a little bit. You can see the temperature here is steadily increasing, despite the red AC releasing at only 464 Kelvin. It's actually just turned off, but that's 200 degrees lower than the pipe temperature here. The reason this now turned off is because this one pushes a lot more moles through than these are pulling in. So this one is going to turn on and off quite a lot, but it doesn't really matter. So the main job of the blue ACs is actually just to gather air at the lowest possible temperature for the red AC to further cool down. Okay, so I gave it another in-game day, and as you can see, it's now at minus 221 degrees Celsius. And at this point, the blue AC is basically heating the blue pipe by releasing the gases at 80 Kelvin. But I promise you, this is not going to stop until it reaches basically absolute zero, sooner or later. The last thing I wanted to show you was that there is an alternative to setting up the red AC, and that's to set it up in a config like this instead. By connecting the output and input to the same blue pipe network, we don't really care how much moles it pulls through, because it's going back into the same network anyway, and as long as it's cooling it down, it's fine. But this reintroduces the pipe length problem, but not in the same way. It's more of a minimum pipe length before this is effective. So on the other side, it's easier to set up. There's no logic behind it. It's just to start and back pressure regulator, and you're good to go. It obviously doesn't deliver anything less than negative 200 degrees, so it wouldn't really work to get this on this pipe. But if you have a heavy load, a continuous heavy load, then you'll get more out of setting up the feedback with this setup instead, because this will, depending on your pipe length, release less moles into the red pipe. So it kind of depends on your need, either or both. But you can't use this setup the other way around. You'll still have to use the blue pipe, the blue ACs to fill the blue pipe again. But anyway, these are your options, I guess, to have a closed loop system without releasing or taking in any gases. So now it's just for you to use this however you like, whatever you need to cool or heat or whatever. You can cool your base on Venus and heat the furnace all in one go. It's all up to you and how you deploy it, I guess. Anyway, I'll of course upload this world, and just keep in mind that PID controllers are not very finely tuned, and it's done fairly roughly here, but anyway. So yeah, thanks for watching.